Now we are going to discuss about aliasing. Okay. So the aliasing is an effect that causes different signals to become indistinguishable from each other during sampling. So that means the aliasing is nothing but the distortion. So when we are recovering the original signal from the sampled signal, so during the sampling process we are recovering the original signal from the sampled signal. Due to the distortion effect, so the original signal, the recovered signal is different from the original signal. Okay, so during sampling process we are converting the original signal into the sampled signal. So in the process of resampling, so when we are recovering that original signal from the sampled signal by the use of low pass filter, the recovered signal is different from the original signal because of the distortion. So that distortion is known as aliasing. Okay. So normally the distortion is happened due to the overlapping of the sampled signals due to the low sampling rate. Normally the aliasing effect is happen in under sampling condition. So under sampling condition means the sampling frequency is lower than twice of the maximum value of the message signal. So that means Fs is less than 2 Fm. So it's having low sampling rate. So under this condition the overlapping will happen. So due to this overlapping, when we are recovering that original signal from the sampled signal, it will be distortion. It's having distortion. So normally the distortion, so the aliasing is characterized by the altering of output compared to the original signal because of resampling. So during the time of resampling, the original signal is differs. Okay, so that is the aliasing effect. So normally the aliasing can also occur in videos. So here that effect is known as temporal aliasing because it is caused by the frequency of the frame rather than the pixelation of the image. Due to the frequency of the frame, there will be some aliasing effect on the videos. So that will be temporal one. Again, the aliasing effect will happen in the audios itself. So in audios means as a result of aliasing, so it leads to poor sound and quality. Okay, so the aliasing will happen in videos and audios. So to avoid this aliasing effect, we can use anti-aliasing filters. Okay. So now we are going to see the aliasing effect in brief. So normally in sampling process we have three conditions: oversampling, Nyquist and undersampling. Okay. So Nyquist means is nothing but the frequency Fs equal to 2 Fm. And oversampling means in this oversampling time the sampling frequency should be greater than 2 Fm. And undersampling means the sampling frequency is less than 2 Fm. So these phenomena will be discussed in the sampling theorem. Okay. So for oversampling, Fs should be greater than 2 Fm and undersampling Fs less than 2 Fm. And one more condition, Fs equal to 2 Fm. These are the three cases of the sampling. So listen here, this is the frequency, sampled frequency of the signal over sampling. So here Fs greater than 2 Fm. So now this is the diagram. At these conditions, the frequency of samples are not touching to each other. Okay, so this is the diagram of overlapping. Now, if Fs is greater than 2 Fm means the frequency of the samples are not touching. So, when you are recovering the signal by using low pass filter, it will not be distorted. It will be easily recovered from the sampled signal by the use of low pass filter. The original signal can be easily recovered. And here this is the second condition, undersampling. So undersampling means Fs less than 2 Fm. That means the sampling rate will be low. When the sampling rate is low means the overlapping will happen. So this is the overlapping. So the overlapping of the signal will happen. So finally, when you are recovering that original signal from the sampled signal means at the time, due to this overlapping, there will be some distortion in the signal. Okay, so we are calling this distortion as the aliasing effect. So due to that distortion, we have some problems in the signals. So in audios and videos, it will be make some disturbance. And this is the third condition. So this frequency Fs is named as Nyquist rate. So now when Fs equal to Fm, this is the third case. Now here the sampled frequency are touching with each other. So in this condition also we can recover the original signal without distortion. So for oversampling and this condition, we can recover the signal, original signal by using low pass filter. In the case of undersampling only, here the Fs less than 2 Fm means the sampling rate will be low. In this condition only the overlapping will happen. Due to this overlapping, we have some distortion in the original signal. When you are recovering by using the low pass filter, there will be some distortion. So that is the aliasing effect. So next, to avoid aliasing, we can use pre-alias filter can be used. And the next one, we have to choose the sampling rate should be greater than or equal to 2 into Fm. So where the pre-alias filter can be used means before we go for sampling, we pass the original signals through a low pass filter. That name is pre-alias filter. Okay, so the another name of pre-alias filter is band limited filter. So before passing through the sampling, we are giving that signal, original signal, into the low pass filter. So here the band will be limited. Bandwidth will be limited. Now the signal will be filtered by using pre-alias filter. So these are the two choices for avoiding the aliasing. Okay, first one, pre-alias filter we can use. Next one, we have to choose the sampling rate. Fs should be greater than or equal to 2m. It should not be less than 2 Fm. Okay, thank you students.